click on the mic, but it seems does not respond. So I just told you that I have created a ULearn link for the assignment submission, and the deadline has also been postponed for another 2 days, just to give you more time until this Sunday. And also you owe me one more quiz actually, that worth I think 2.5% or what. So normally I will, for quiz I will just make a multiple choice question. Is it possible? Then I will normally I will give you some period for you to answer that quiz, that may be for 1 day or 2 day, that you can take the quiz. So I will upload. So what do you think that can be suitable? I will suggest, is it possible to make a quiz on BJT? Okay. So I would say normally for 2.5%, the quiz will just take around not more than 10 minutes. Okay. So so which means 10-minute quiz normally around if you divide by 1.5, 3, so 2 questions give you 3, so around 6 to 7 questions, maybe 6 questions. Okay. So okay, so I will say for the quiz, so get ready to answer, get ready by preparing yourself with theoretical parts on BJT. So multiple choice question, around 6 to 7 question, around 10 minutes. Okay, posted in the chat section. For the quiz, get ready by preparing yourself with theoretical parts of BJT. There will be multiple choice question, around 6 to 7 questions, and will take around 10 minutes. Okay, so normally I will announce once it's ready. Okay, for today actually, okay, I give you another maybe 2 minutes. If you have any concerns or any issues that I have overlooked before we proceed with operational amplifier. Okay. Philip, what?
The quiz will be tomorrow, or what
time?
Okay.
Is it possible if we do next week?
Yes, it is.
Okay, I think expected. So it will be just a multiple choice question, and normally I will do in ULearn. Expected quiz around next week. Okay. And normally I will give you 1 or 2 days to answer that. Okay. So okay, if no other questions, then we can proceed with the last material for this subject, which is operational amplifier. So I can switch off my camera. So share content. Screen. Okay. Actually, yesterday I have forwarded a YouTube video that is, I think, very nice and very clear on explanation about operational amplifier. So I hope you have watched the video by this point. I'm just wondering if we play the video now, can you hear the sound as well?
No, doctor.
No sound.
No sound.
No sound. Okay. So what I will do is I will turn on the subtitle. And then what we can do is I will open the slide, which is meant for today's lecture. And then okay, I thought I have opened it, and then we can take interesting snapshots and immediately discuss in the slide. Okay, this is an addition to what the slide is already have lah. Okay, so no problem. The most important thing is you get the main point. Okay. So this guy, this lady is just mentioning about operational amplifier. Oh, okay. Sorry. Oh, what happened? Now I need to go back to previous one. Called op-amp. Okay, so this is a very important statement here. What the lady has just made is that stating that I will print screen and put in the additional slide to the slide. Okay, is that an op-amp is a high gain. Maybe I should make it bigger. And DC voltage amplifier. So the keyword here is voltage amplifier. So this is what separate op-amp and BJT, because as you know, BJT is a current amplifier, while op-amp is a voltage amplifier. So this is the key point that you should take away after this lesson. Okay. That is the main difference between BJT and op-amp, where op-amp is a voltage amplifier and BJT, the bipolar junction transistor, is normally a current amplifier. Okay, so if I go back a little bit, okay, so this is also a very important statement here. If I uh, print screen and put it here, is that when she mentioned a voltage difference, okay, between its inputs. So you see inputs here, you have S, which means the input is more than one. So this is another important criteria that one should note when discussing op-amp, is that the input, unlike a BJT which has only one input, say, so if you can recall a BJT, okay, so we can say that the input is actually the base current is the input. So you have only one input, and so we can say that input is IB and output is IC, and IC is an amplified version of IB by amount of beta. So that is BJT, but an op-amp, it has more than input that you will see later. It has more than one input. So what take is different between these two inputs. So this is not that important. It's just an explanation on the different physical packaging of an op-amp. Okay, so this is the internal circuits of an op-amp or operational amplifier. So basically, it is not that accurate that I compare BJT and op-amp, because if you see here, an op-amp is made of many transistors. So we can say that an op-amp is actually a system of transistors which arrange so that it will behave as a voltage amplifier. So while transistor is more fundamental, it's more it's like maybe the smallest building block that are available. Okay, so this is again the internal circuitry. Okay, this is the, I mean, the symbol for operational amplifier, op-amp, and as described earlier, an op-amp, it has two input, okay, as compared to BJT with only one input, but op-amp has two input. One is called inverting inputs, and the other one is non-inverting input. Okay, so this is as denoted by the symbol here, positive and negative input. And however, there is only one output. Okay, so you have two inputs and one output. So we can say that two inputs but one output, and this is a positive V supply, and this is a negative V supply. Okay, so you have to supply voltage to the op-amp in order for it to work, and the other inputs are normally just for fine tuning. So if you see for the voltage supply, you can either connect it to positive and negative, or also connect it to positive and ground. Okay, so this is the difference. between these two settings. Okay, this is just an example of circuit how you can connect it. Okay, so since we have two input, what will happen is that the circuit will actually the difference between the two inputs for the amplification purpose. Okay, so okay, this like different. So it will be differential input values. Okay. So how much is the gain for the voltage? So actually, the gain for an op-amp is very large. Okay, so this is already. So if you see here from the datasheet, the gain here is 200 volt over millivolt. So which means 200,000 times gain. So one of the most powerful feature of an op-amp is the gain is very high. Okay, so you see here even from the datasheet, I mean for the datasheet, the gain, this is how we normally is denoted as A, where A is actually output of an input. So it's roughly 200,000. So if you can recall in BJT, it's around maybe 200. If you recall back for BJT, the beta is maybe around maybe 100 or 300. But in the case of op-amp, it's very large. It can go up to 200,000 times bigger. Which means even if you have a very small voltage difference, it will be amplified greatly. Okay. So if you see here, 9 volt, yes. See here, what I mentioned here is that, okay. So this is example where you have example where the voltage difference is just V different. It's just 1, 2, 3, 4, 5, 6, 45 microvolt, and then V out will be gain multiply V diff. So since gain is 200,000 multiply 45 microvolt, immediately you will get 9 volt at the output. So if you can imagine, 45 microvolt is very small. It's a microvolt. I mean, I don't think I don't know how much voltage electrostatic voltage that you can make just using your finger, but that can, I think, in that range already. So you can turn that signal into 9-volt signal already. But this is also, too much is also not ideal. Okay. Because it will immediately go to the maximum values. So this is already, she's already explaining different types of circuit. Okay. So what happened is that, where can I make it? So, okay, I will stop here with the video. We will start our explanation from this point here. I will put maybe, however, having too big, having a gain of having too high gains, a very high gain, having a very high gain, and also means that the output will immediately hit the maximum or minimum value is called V saturation, even with a very small voltage input. Okay, so just give yourself maybe around 15 seconds, try to get understanding of what I have written here. However, having a very high gain also means that the output will immediately hit the maximum or minimum values of V saturation, even with a small voltage inputs, which means, as we seen earlier, even just by having 45 microvolt, it will hit 9-volt straight away. So why is this case? So the question now is, how much is V saturation? How much is V? So V saturation is defined by V supply. So how much is the saturation voltage? The question. So the answer to that question is that the VSAT. So VSAT. Okay, so we can say that the positive VSAT is equal to the positive V supply, and the negative saturation, which means the in negative direction, is equivalent to minus V supply. Okay, so which means this is why we have, okay, so we have I go back to a screenshot that I have done earlier. So you can see that these two parameters here will determine your maximum output voltage. So this will give you the positive side of the V saturation, and this is the negative side. So for example, if you connect here, example, if here you connect plus 9-volt, and here also minus 9-volt, so your V saturation is then plus 9-volt, and the other direction is minus 9-volt. So that's why your value, your output will drive to the maximum or to the minimum, depending on the voltage input. So I will now go back to my slide, to the to the early beginning of the slide for chapter 6. So okay, we can skip this one first. Okay, so this is again the symbol, and again you have the positive supply, the negative supply, and then this is we call this one as inverting input because it has a negative, and positive one is a non-inverting input. So and then have this explanation on the for the ideally an op-amp, it has an infinite voltage gain. So for an ideal op-amp, A is actually infinity. Okay, but for practical op-amp, of course, in reality you cannot achieve infinity, but still it's a very high voltage gain. As you can recall, just now we see example is 200,000, or equivalent to 2 to the 10 power of 6. Okay, so these are typical values of the gain, which is very high. And okay, so what will happen is that okay, what will happen is that since you have two inputs, one is the positive one, the non-inverting, one is the negative, is inverting. So the operational amplifier will consider the VD, which is a V difference, which is denoted by V in minus V in 2. So in this case, the non-inverting minus inverting input, and only then the gain, this is the gain, will multiply the V difference. Okay, okay, this is the slide that I want to come into. So what happened is that in open loop, I mean this in by default, gain is very high, as discussed earlier, and cannot be controlled. Okay, so for example, a comparator. We'll talk about a comparator. Let's go to the comparator circuit. What does it do? A comparator, as the name suggests, compares two input voltages. Okay, which is the, you should have, so what people normally do is one input we will set as a reference voltage, and the other input will be the signal from our sensor, which will then be compared to the reference voltage, which means comparison is mathematically just what we call subtraction. Okay, and then so you will subtract, where the subtraction result will then multiply, or will then be amplified by A0. So your output will then be just, it's either high or low, depending on what values that you supply to the, it is normally people will not draw the V supply here. Normally is V in here. Is it V in or I think V supply? Positive V supply. And to the positive V supply. Okay. And so if you put example 9 volt and it's minus 9 volt. So example, if you define 9, it can be 9 volt or example I will put this example. Normally in electronics, normally they use 5 volt and low maybe minus 9 volts. So let's take a look at the comparator. So you see here, the in this case, the reference value is grounded. So the Vref is equivalent to 0. So that's why for this specific circuit here is referred to as zero level detector, because now you want to compare whether at which point your signal intercept with 0. So this can be from your sensor maybe. So this is the V in, and what happens that the V different will then be V in minus 0. So in this case, the V different is positive, and in this case, V different is negative. So positive value multiply a very high gain, immediately you will hit the positive saturation value of the maximum, for example 9 volt, and in the negative part immediately you will get this. So this is how it works if you not using any, if you use the op amp as it is, okay, which mean by default condition. So which mean so it just act like a switch, so you can only achieve either on or maybe off state. Or if you, for example, it's not necessarily a 0 level that you want to compare with, you can also put some value in some voltage value in the reference, for example in this case a certain value. Or you can also, another option, you can use a potential divider to set the reference voltage, which is then determined by this famous potential divider formula. And then this is where you put your sensor signal. This is where you put your sensor signal. So then your sensor signal, the yellow ones, will then be compared to a reference value, in which if your Vref is bigger, if your I have to color this one. So in this particular zone here, your V in is bigger than Vref. So you get on value or positive value. And in this range, your V in is lower than Vref. So immediately you get off values. Okay. Okay, so this is what we mean as comparator circuit. So a comparator circuit is basically compares the two values. In this condition, in this arrangement, we call this as a type of a open circuit op amp. Okay, now I go back to the how they characterize op amp circuit. Open loop also. So it's open loop circuit. in which if now I go back, in which this is what we refer to as open loop. Open loop. And the other options that we have is called as closed loop. On the right hand side here, you have a closed loop. What is meant by closed loop? Closed loop is when you use feedback. When you have a feedback, you take from the output and then you feed it a portion of the signal back to the input. So this is what we refer as a feedback. Okay. So if you apply this type of circuit, we are referring this as a closed loop circuit, and there is a reason why we want to do feedback, because if you do feedback, now we have the ability to control the gain. So you see here, if you do feedback for this type of circuit, the gain is now, instead of a very ridiculously very high value, now the gain is defined by the ratio of the feedback resistor versus the input resistor. So if the ratio is 100, then the gain is 100 instead of 200,000. Okay. So I go back to one more slide earlier. So this is how we can categorize op-amp circuits by whether it is open loop or closed loop. Okay, where if you use it in open loop, we can say that the gain is almost infinity, or around maybe 10 to the power 5 or 10 to the power 7. Okay, but if you use in closed loop, the gain is is determined by the ratio between RF, the feedback resistor, and the input resistor. So under open loop, we have only comparator circuit, but it's actually under the closed loop circuit, we have another series of circuit that we can have. We can have an inverting amplifier, a non-inverting amplifier, we can have a voltage follower, we can have a summing amplifier, we can have an integrator and differentiator. So for this particular subject, we will not consider this one. Okay, we will not consider this one only until summing amplifier. So please, you can bear in mind, for example, these four type of closed loop circuit. So let's take a look at the first one, which is an inverting amplifier. So this is what we refer as an inverting amplifier. Is when you ground, the non-inverting input is grounded, as you can see here, and your signal V1, this can be, for example, from the sensor signal, for example, will then be fed into the inverting amplifier, and a portion of the output signal will then be fed back to the inverting input. So in this condition, the gain is given by this formula here. So make sure don't forget the negative sign. Yeah? That's why it's called inverting amplifier. So you have a negative for inverting. Okay, example. So for example, okay, the question here asks determine required RF. So what is the required RF? To produce a closed loop gain of -100. So it's just an application of formula by this one. And then you get RF should be 220 kilo ohm. Okay. So what happens is that the gain is 100. So if we draw the signal, if you can, let's say we have a sinusoidal signal here as the input, and this is time, and this is the input signal. Okay. So the output will then be, let's draw in green, the output will be 100 times, maybe this is not 100 times enough. I still you should draw to make it bigger. But however, it's inverted. So if you can draw on the same scale here, the output maybe, oh, no, make a mistake. Once again. Okay. So this is output, V out. So V out is 100 times V in and inverted because of the negative sign. And the red one is maybe V in. Okay. So this is what you get if you connect to an inverting amplifier. However, if you don't like inverting effect because now the signal is inverted, you can use non-inverting amplifier. Okay. In this case, the input will come through the non-inverting input. The input, for example, from your sensor. The input signal may be from the sensor, and in this case, now the inverting input will be grounded. However, with some portion as well by the one called feedback resistor. So this is if you want to easily memorize or differentiate between inverting and non-inverting amplifier, you see, for inverting it's always the non-inverting input, the positive input will be grounded. But for non-inverting amplifier, now the negative input or inverting input will be grounded. So the rest is just formula. This time the gain is determined by this formula here, 1 plus Rf over Ri. So you see here there is no longer negative signs there. So let's take a look at one example. Okay, so the question is just ask the gain. So in this case, you end up with 22.3. The gain is 22.3. So, for example, if V in is equivalent to let's say 5 volt, then V out will be A multiply V in. So in this case, 22.3 multiply 5 volt. That will give you how much? I don't know. Maybe you can take a calculator. My calculator. Or even Google can do for us. 2.3 multiply 5. It's 111.5. 1.5 volts. Okay. Remember, now we are working with voltage already. Okay, this is of course if you're talking about DC lah, example DC. We can also have a AC signal as input. Then example will be this AC signal. So your output will be just, it's no longer inverted. So the okay. So the output will be just V out is equivalent to 22.3 times V in. And the most important feature is it's not inverted. Okay. Okay, and then another one, if you see, if you take a non-inverting amplifier and then you remove the two resistors, you will end up with a voltage follower. Okay, so what will happen is that the unity gain is 1. Okay, so if you can recall, for non-inverting amplifier, the formula is 1 plus RF over RI gain. So it's basically a specific type of non-inverting amplifier here, a voltage follower. So 1 plus RF over RI. But since RF and RI are 0 for both cases, so this will give you, but it should be 0 lah. This will give you 0. So you will end up with 1. Okay. So so what will happen is that V0 will just be equivalent to V1. V1. Okay. So there is a reason why we need a voltage follower. This is because an op-amp, the internal resistance is infinity. Okay, so if you want to separate the input and the output, okay, the load is normally what we call an output. So you can use a unity voltage follower. Okay, so we come to our second last type of circuits. Previously, we have 3 of circuits already. One is inverting amplifier. The second one is a non-inverting amplifier. The third one is a voltage follower. Now we come to our second last or fourth type of circuit, which is a summing amplifier. So if you notice here again, the non-inverting input is grounded. So this is like an inverting amplifier with many inputs. So it's just like a specific type of inverting amplifiers. How you know this inverting amplifier is also because you have a negative sign here. So this means it's an except now it receive, in this case here, 3 inputs. So which is a V1, V2, and V3. So the output will then be just defined by this formula here lah. Okay, depending, you can also have up to 100 inputs or 1000 inputs depending on the application. The formula will just grow with the number of input. Okay. So I think this is straightforward because we have covered inverting amplifier just now. So a summing amplifier is just a specific type of inverting amplifier. So this is an example of calculation. The question asks calculate V out. So what you will need to do is just you have three inputs, 3 volt, 2 volt, and 8 volt. Okay, so the first input, the ratio is 10K divided by 47K, and this one is 10K divided by 100K, and this one 10K divided by 10K, and then this is V1, V2, and V3. So you mean it's just application of formulas is how you're going to solve op-amp circuits. So that's why I say op-amp is actually easier than BJT. Okay, last one. The last one is you can combine. This is what I asked you in the assignment, that in the problem 3, where I stated that you are required to take any multi-stage operation amplifier and try to simulate it. So a multi-stage amplifier is just like a combination. So basically a combination of 2 or more op-amp circuits. Okay, so don't be afraid by the name. It's just if you have, for example, in this case, you have 3 types of circuit. So the first one is can somebody enlighten us? What type of circuit is this?
Non-inverting.
Okay, good. So this is a non-inverting. And this one, you see clearly the plus input or the non-inverting input is grounded. So this must be an inverting amplifier. And the last one is also an inverting amplifier. So that's why what you need to do is just take the specific formula for each types. In this case, for non-inverting, 1 plus Rf1 over R1. For inverting, it's the same formula, but different values depending on the feedback resistors. So the overall gain will then be just AV multiply A1 multiply A2 multiply A3. So example calculation. Okay. So I think this circuit is same as the previous slide. So the first part here is this one, and then this is the second part, and this is the value for the third one. So you get the gain for the first part, you get the gain of 10. For the middle inverting amplifier, you get minus 18, and the last one, the third one, minus 27. So 10 multiply minus 18 minus 27. This is already the input. Yeah, the input is 150 microvolt. So this will give you. So at the end, you will end up with a non-inverting amplifier, because you have a negative multiply negative, it will give you positive back. So you can say that you can 10 multiply 18 multiply 27. Oh, okay. wrongly key. Okay, equivalent to 4860. So the gain is equivalent to 4860. This is the gain. Okay, so you have, I think it's very powerful. You have a circuit that can amplify a very small voltage 4,860 times of its original values. So that's why people will use op-amp for sensors, because sensors are needed to, for example, to sense a very small signal. For example, if you want to have a sensor that will detect a human pulse from for example, your smartwatch, your watch, maybe your running watch that comes with a pulse sensor. You can imagine that the sensor is very weak. So when the sensor detects your pulse, maybe the difference voltage is very small, maybe in microvolt. So you have to amplify the microvolt difference signal into normally your electronics work in 5 volt, 0 to 5 volt. So you have to amplify it to 5 volt value. So you need maybe an op-amp to amplify it so that it can be usable in your circuitry. Okay, so this is just another example of multi-stage op-amp. Okay, in this case you have a non-inverting amplifier here. Okay, you see, yeah, you see now for the first one, the negative input or the inverting input is grounded, and then the second part here you have a voltage follower. Here you see that feedback is short circuit straight away without a resistors, so it's a voltage follower. And the last one, you have a summing amplifier where you have 2 inputs and 1 feedback resistors. So how does the V out looks like? You just have to, so this will serve as the input for the first summing amplifier, and then the voltage follower will be fed to the second input of the summing amplifier. So which mean okay, so yeah, then you get this is the final value lah. Okay, so that will be the end already for this semester. Maybe I'm not sure. This is the slide from the video link. I hope you can relate the videos with my lecture above. And okay, so let's try to okay, this is another, for example, a real application of op-amp and BJT. You can see straight away when to use op-amp and when to use BJT. So as explained earlier, an op-amp is normally used for sensors, while BJT is normally used for actuators. Okay, actuators, for example, actuators can be a motor or a solenoid, or maybe a pump. There's an actuator part, something that do works. Well, sensor is actually the opposite of actuator. It turn physical quantities into electrical quantities. So this can be maybe acceleration sensor, maybe in this case it's a temperature sensor, and many type of sensors. So what type of a circuit that we have here? Can somebody enlighten us? Op-amp circuit. We have no feedback. So this must be a comparator circuit, okay? So this is your VREF. Your VREF is set by the potential divider, and your V in here from the sensor will then be compared to a reference voltage or a reference temperature, so that when it reaches a certain reference temperature, it will turn on. It will turn on the BJT here, so that the relay will be switched. Okay, will act like a magnet. Okay, once you have a current flowing here, the relay will be energized, so it will pull the contact here to this one. So it will turn on. For example, an air conditioning. For example, if you want to turn the aircon at a center temperature, so this is how maybe the type of circuitry that you will need. Okay. Or also maybe for a solar tracker, where the orientation of the solar panel should face directly to the sun. So what you will have is then you need to, okay, you need to somehow turn. How does this circuit works is that it will turn on the voltage here will vary depend on the light intensity. Okay, V out here and V out here will depend on this light intensity at LDR1 and LDR2. So depending on the voltage at, for example, V out 1 and V out 2, okay, you will get a different current flowing. Okay, if the current flow, for example, from this side to this BJT into the motor and go outside this BJT and go to the ground, so your motor maybe will rotate clockwise, for example. But if you have your current flows to the right side of BJT and then from right to left into the motor and then through this one and then to the ground, so your motor might rotate in counterclockwise. So what will determine which path the current will flow is the value of V out 1 and V out 2. The difference in the value will determine which BJT will be turned on. Okay, so this arrangement we refer to as H bridge. It's normally used to control the direction of the motor, because a DC motor will change its direction of rotation depending on the polarity of the voltage that apply. So you will know this if you have somehow disassemble your maybe remote control car when you are still kids, and then you try to switch the battery's orientation. So you will notice that the direction of the motor change. Okay, so I will stop here. Any question? You are encouraged to do the tutorial question. I will strongly suggest that you do the tutorial questions for BJT as well. Sorry, for op-amp. For example, I have uploaded for chapter 6. It's already here. And this tutorial already comes with the solution. So I would say for op-amp is easier as compared to BJT because it's already very user-friendly setup, and because an op-amp is already a system, so it is designed to be easily used already. So where is the original window? Stop sharing. Somebody asked actually. So Nazatul asked a question just now. I didn't notice. Okay, regarding syllabus, you have to refer the regarding the syllabus, you have to refer the teaching plan. So please refer teaching plan. Okay. And then the after Nazatul asked, nilai V supply sama dengan nilai V saturation. How can higher gain value can hit minimum V sat? Okay. Yeah, there's a, if you have a negative input, it will hit minimum. Okay. So to answer Nazatul question, how it can hit the minimum voltage value. Okay, for example, the minimum voltage is, okay, for example, I explained earlier, this one will serve as the positive supply voltage will be the positive V saturation, and this one will be minus negative V saturation. So you will reach, you will hit this one when VDIF is bigger than 0. You will immediately hit this one, and this one if the VDIF is negative or less than 0, so you will hit this one. So that's why in a comparator circuit, if you see here, okay, because in comparator circuit, the okay, for example, this one, you are comparing the yellow signals and this what's the color is the purple signal here. So if your yellow is bigger than purple, which means positive, so you will hit the positive V out. So this is V out max. Out max positive, and this is a negative V out max. Negative V out max when you in the yellow is lower than the purple one, so you get. So which means the drawback in this open loop setup is that you will only either hitting the maximum positive or minimum positive. So you will only have a square voltage, square signals. But if you use in closed loop, you can control the gain so that you will still replicate the input signal in terms of shape and form, but only amplify the amplitude. Okay, that's the whole purpose lah. Okay, So any more questions? So by right, we have covered everything for our lecture for this subject. Of course, I hope you can be independent with the tutorial section, because the tutorial will, because the exam are mostly calculation and also a few theoretical questions. So your tutorial will help you as your exercise. Fardin, what book are you referring to when you ask me? Whole book? Floyd. Floyd is a good book. Floyd or Ballstadt. However, for this particular subject, it covers only a little from Floyd. Only a few chapters only, not everything. Okay. So, okay. The answer to Daniel's question, if we increase V in for the multi, so whatever value that you, whatever value it is, the output will be saturated at the input values. Okay. So, for example, your V supply here, your positive V supply will act like a limit to your output. If it hits the limit, the signal will be distorted. Okay. So the answer to Daniel's question, yes, if the output reach saturation value, then it will be clipped or distorted. Okay. Yes. So. Okay, so if you don't have any more questions, you are free to leave. If not, you are free to ask more questions. I will stop recording.